Hi all, this is Alan with Bothell STEM Coach, and today we are going to continue on with some AP Physics 1 free response questions, and we are looking at electrostatics. So I should check through the problem to make sure there's no aspects of the problem you can't do before you're trying it. Electric force, don't need to calculate electric potential. Okay, let's try to do all the other parts here. So, again, pause the video, attempt to do the problem on your own, and then after you've completed the problem, come back and watch the video. So I have three electric charges arranged in an XY coordinate system as shown above. Express all algebraic answers of the following terms in terms of big Q, little q, x, this distance, and then d, this vertical distance. On the diagram, draw vectors representing the forces F1, F2 exerted on the positive charge by plus q and minus q. So this is a repelling force, so that means in this direction he's going to be drawn this way. This is F1. And then F2 is a force, and it's an attractive force, so it's going to be drawn towards this one, F2. Okay, so that's A. B, determine the magnitude and direction of the total electric force on the plus charge. Okay, so let's first, so the way you want to think about this is when you add two vectors, is I want to calculate the magnitude of each vector, and then I want to know the angle. So let's do the magnitude of F1 first. Magnitude of F1 is K Q1, Q2, this is Coulomb's law, over R squared. And that's K, Q1 in this case is just Q. Q2 is Q. And then R is this distance. The distance squared, this is R here, which is equal to the square root by Pythagorean theorem, x squared plus d squared, right? So R squared is just x squared plus d squared, okay? Now, magnitude of F2 is the exact same thing, right? It's just the direction's different. So now I want to look at, so because they're the same magnitude and the same angle, I hope it makes sense to you that the x component of the vectors are going to cancel out. And the only thing that matters is the y component, okay, of each one. And they should be the same y component. Okay, so if I want the F1, the y component of this vector, I need to know, like, I need to draw this, and I need to draw a little triangle. I need to know some angles. Well, these are similar triangles because this angle is the same as, say, this angle here. Okay? We'll call this angle theta. This is theta here. Theta in this case is, so F1y is going to be, the y direction is going to be F1 sine of theta, right? Because if this is the theta, the opposite side, the y component, is this one here. It's sine theta. But sine theta, from this triangle, I know sine theta is opposite over hypotenuse. So that's F1 times d over this. D over square root of x squared plus d squared. Now, you could do things like sine inverse or tangent inverse or whatever and then do the cosine of it. But it's simpler to just use this triangle to compute the sine of this angle, which is what I want to use here. Okay, so that's F1y. And then, again, F2y is going to be the exact same thing. So the y the total force vector, which is just the y components, is going to be 2 times F1, which is K, Q, capital Q, over x squared plus d squared, times d over square root of x squared plus d squared. So that equals, I don't know, 2kq big Q d over, and this is x squared plus d squared to the 1 times to the 1/2. That would be x squared plus d squared to the 3/2. Okay, just a little simplification. Okay, yeah, and it's downward. Okay, so that's the magnitude of the force, and then the direction is downward. Determine the electric field at the position of the plus q charge due to the other two charges. Okay, what you simply do is you just divide by our test charge, our q. So the electric field is the force divided by q. by this charge here, and it's just equal to all of this part, which is 2k qd over x squared plus d squared to the 3/2. Okay. So that's C. This is C right here. This is B. E. The charge plus q is now moved along the positive x-axis to a very large distance from the other two charges. So I'm going to move this charge, I'm going to move it way out here. The magnitude of the force in the plus q charge at this distance now varies as 1 over x cubed. Explain why this happens. Well, when x is very large compared to d, okay? So when x is, say, much, much bigger than d, then we say x squared plus d squared. This term is small compared to this. Is about equal to x squared. Because this could be like 1,000,000 and this would be like 10, right? And so we just ignore this. That's sort of an approximation we're going to make. And so then the force is approximately equal to 2kq qd over x squared to the 3/2. X squared to the 3/2, I multiply exponents, right, when I'm doing powers to each other. So that's 2kq big QD over x cubed, because 2 times 3/2 is 2. And so that's why it varies as 1 over x cubed. Like you just derived this sort of the equation. Okay, hope you found that helpful. I'll see you in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.